This is section 27, Limitations of Significance Testing from Making Sense of Statistics. Well, let's cover four important concepts that we learned from sections 20 through 26. So remember that the null hypothesis attributes differences to random sampling error. So what it is saying is that any differences observed in the random samples, such as the difference between the means of an experimental and a control group, are only chance deviations from a true difference of zero in the population from which the samples were drawn. The second important concept you should recall from sections 20 through 26 is when there is low probability that something is true, researchers reject it, which realistically makes sense, right? So if there's a low probability that the null hypothesis is true, such as p is less than 0.05, researchers reject the null hypothesis. So in sections 22 through 26, you learned about some of the specific statistical tests that researchers use to determine the value of probability for particular types of data. So we covered the t-test, if you'll recall that one. We covered the one-way ANOVA. We covered the two-way ANOVA, and we covered chi-square. The third important concept from sections 20 through 26 is that they're making the correct decision when rejecting a null hypothesis. So for example, if a researcher rejects the null at a p at equal to 0.05, there are 5 chances in 100 that they're incorrectly rejecting it. Now remember, we talked about this from the number of days that it would rain. If the weatherman said it's a 5% chance of rain. So if you have forgotten that, go back and review sections 20 through 26. So if a significance test allows us as researchers to reject the null at the 0.01 level, we're only taking a 1 chance in 100 that the decision to reject it is incorrect. If you're still confused about the levels, whether it's a 0.05, 0.01, 0.001, go back and look at that particular section. And the last important concept that we're going to discuss as far as review from sections 20 through 26, when a null hypothesis has been rejected, we as researchers declare the difference being tested statistically significant. Now, typically, as researchers, what we hope to find is that the differences are statistically significant and that they are highly significant at the levels such as 0.01 or 0.001. Now, reliable reliable results are ones that researchers can count on from observation to observation, and reliable because it's unlikely that these results are due to random sampling. And what this does is this allows us to state in our research report that the differences that we observe in our research is very probably highly reliable, and reliable results are the ones that we count on. Now, similar to this, if we talk about an employer, saying an employee is reliable, the employer means that the employee can be counted on time after time to do their job in a consistent manner. And so just as employers are searching for reliable employees, we as researchers are looking to identify reliable differences. Now, a lot of times people will make the mistake of equating a significant result or a reliable result with a large difference, and it's not always that way. So let's look at an example briefly to show you what a small difference can make. So an individual notices that the number of minutes of daylight is very slightly larger on December 22nd than on December 21st, which is, as we know, the winter solstice and the shortest day of the year. So the researcher decides to sample the next 75 years and makes the same measurements. So for every year, the researcher gets the small difference, and when comparing the number of minutes of daylight on December 21st with the number on December 22nd. So what the researcher will do is conduct a t-test on the difference between the average number of minutes on December 21st and the average on December 22nd. And what the researcher finds is that she has identified a statistically significant or a reliable difference. But the difference, even though reliable, is actually quite small. So let's review in section 22. We were looking at the three factors that are mathematically combined to determine the significance of the difference between the two means, and we were looking at the t-test. And what we have to look at these three factors is the size of the difference, the size of the sample, and the amount of variation from one observation to another. Now in example 1, we have the size of the difference is small. Now also, if we look at the size of the difference is small, but the size of the sample is reasonably large, which is 75 years, N of 75. And what we're saying is there essentially is no variation from year to year. The number of minutes of daylight on December 21st is the same for each of the 75 years. And what the lack of variation indicates that it is a statistically significant difference or a highly reliable difference that has been observed, even though it is a small difference. Now, small differences can be statistically significant. They can be and are reported in all of the sciences, especially in social and behavioral sciences. And for the research consumers, it is not sufficient to know that the difference is statistically significant. You also have to know the size of the difference. So you might have to be able to say that XYZ is statistically significantly higher than ABC without discussing the magnitude of the difference, as though statistically significant is equated or equivalent with being large. So that is actually, you should not do that. Now, a small difference is less likely to be of practical importance than a large difference. but it is also true that even a small significant difference can sometimes be important. When we're looking at practical importance, as researchers, maybe someone found out that making a small change or a very modest change in the diet created a small decrease in the side effects of persons going through chemo. So if the difference was statistically significant, indicating it is a reliable difference, is this small difference of practical importance? Now, that depends. If you're experiencing the side effects and you get any relief from the side effects, you might consider this extremely important, because it might be that it only includes a very modest or inexpensive change in diet. Now, you might be wondering why researchers conduct significance tests, and here let's keep in mind the three-step process in which significance testing comes first. So the first thing is to use a significance test to determine if the difference is statistically significant. Now let's consider an experiment in which there is an experimental group and a control group, and of course, here again, both of these are drawn at random, and that the difference between the means of the experimental group and the mean of the control group is being tested with a t-test. And so we've looked at the significance test, the t-test, to determine if the difference is statistically significant. If it is not, then we go to 2. If it is, then we go to step 3. So step 2, for an insignificant result, the researcher should not assert that the experimental treatment is superior to the control condition. So, just because, we should not say that the experimental treatment is superior to the control condition. Like we've said, there are still some practical implications. But, we might find out that insignificant differences have a practical implication. In step 3, let's evaluate a statistically significant difference in terms of its practical significance. So now we would consider the size of the experiment, and we would also consider the cost of using the treatment. So, let's say if we find an inexpensive treatment, like taking a low dose of aspirin on a regular basis produces a large benefit, such as the very large reduction in the incidence of heart attacks, that actually would be very practical in the cost of using the treatment. And if the treatment produces a small but statistically significant difference, the cost of using the treatment becomes an important consideration. So these are things that we might want to look at.